Okay, to solve a system of a quadratic and a linear is the next part, is part 2. And so we've got a linear right here. We can again tell it's linear because it's mx plus b. And we've got a quadratic because it has an x squared in it. Now, in the previous video, we've already solved these. So we've already solved this graphically. Okay, so now we're going to go through the steps for how to solve this algebraically. The first thing that you do is you take the two expressions. Okay, so the x squared plus 4 and the 2x plus 7, and you set them equal to each other. The order doesn't really matter. Okay, so 2x plus 7 and equals x squared plus 4, because that's, a system of equations is equal where the two functions cross. So we're going to take this and then we're going to solve it. Now, solve it can mean factoring, can mean quadratic formula, can mean completing the square. It really depends on your preference and what kind of quadratic you end up with. Not everything factors, and some of you don't like factoring. The textbook is going to show factoring. Okay, so they're going to start with 2x plus 7 equals x squared plus 4. They don't show this part, so I'm going to write it in. They subtracted 2x and 7 from both sides. It's terrible to have to write with the mouse. And they get 0, because these terms cancel out right here, equals x squared minus 2x, and then a plus 4 and a minus 7 equals a minus 3. Then they took that quadratic and factored it. So x, the signs are different because this is a minus 3, so signs are different. 3 times 1 makes 3, and 3 minus 1 makes 2. And we need the negative to be where the larger number is because that's what the sign here is. Okay? Then what would x have to be in order to zero out that entire term? Well, it would have to be positive 3. So that's one of my solutions. Or x equals negative 1. Okay, so our two solutions, if I sub in x equals 3 here, 3 minus 3 would be 0. And if I subbed negative 1 in here, then that would 0. So those are my two solutions. Okay, let's take a look down here for a second. That looks awfully familiar. Okay, negative 1 and 3. Those are the x values of the coordinates when I solved. Okay. Then I still am not done because I don't have y values. So when I solved graphically, I had an x and a y. I had a coordinate pair. So far, I just have two x's. So in order to get the y, I'm going to sub x equals negative 3. Now it says into the linear equation, and that's exactly what I would do, only because you could sub into either one, but the linear equation is easier. It's less complicated than the quadratic, less steps. So 2 times 3, I subbed the 3 in here, is 6 plus 7 equals 13. Substitute x equals negative 1 into the linear equation. So y equals 2 times negative 1 plus 7 is negative 2 plus 7. So that's 5. Okay. Then, what are the solutions? Okay. So if we subbed in a 3 for x, the y value is 13. So 3 and 13. Then we subbed in negative 1, and we got 5. So negative 1 and 5 are the two solutions that we got algebraically, and that's exactly what we got graphically. Okay, this is another system that we already solved graphically, and we have negative 1/2 and 5 is the solution. solving algebraically, we set the two equal to each other. Then we're going to set equal to 0. So set equal to each other, then add 2x and subtract 4 to both sides to get it equal to 0. Now, I could factor this. However, I just showed factoring in the last example, so I'm going to choose to show quadratic formula this time. Okay, A, B, and C. So my words say that you can solve using the method of your choice, but I'm going to show quadratic formula. So -4 plus or minus the square root of 4 squared minus 4 times A times C all over 2A. Then remember, we're going to evaluate our discriminant. Look at our discriminant, put that in. Oh, and it's 0. Well, that's awfully nice, because then our square root's 0, so we only have one solution. So -½ or you could put it in decimal form. Okay, that's just the x value. Then I have to take that -½ or -0.5. These are the same. I did not get two solutions. I just expressed my only solution two different ways. So I'm going to sub in. I chose to sub in with a decimal into the linear equation. So -2 instead of times x. I'm going to sub in the -0.5, add 4, and I get a y value of 5. So that makes my full-on solution -0.5 and 5. That is my final answer. Okay, and remember, if you don't put the coordinate pairs or pair, that's the answer to your question. If you don't go as far as taking your x value and your y value and rewriting them as a coordinate pair, you didn't answer the question yet. You've just done the work to get the answer. So make sure you state the answer as a coordinate pair. Okay, and one last example. We've already done this one graphically again, and there's no solutions to this one because the parabola and the line didn't cross. So we know what that looks like graphically. Let's see how that looks algebraically. So pretend you don't know that there's no solutions, and you do what we've been doing, which is take the two and set them equal to each other. So 3x squared plus x minus 3 equals -4x minus 7. Then set it equal to 0, add 4x, add 7, both sides, so that this side zeroes out. And you get 3x squared plus 5x plus 4 equals 0. This may be factorable, but I'm just going to do quadratic formula because I personally, if I see a leading coefficient out here that I can't factor out, it's just as fast to do quadratic formula as it is to do a factoring method like, you know, drag and drop, drop in, drop out, or whatever you want to call it. So I'm going to do quadratic formula. So A equals 3, B equals 5, and C equals 4. Sub them in. So remember -5 because the formula starts at -b, so -5 equals plus or minus 5 squared minus 4ac all over 2a. And we do our discriminant first. Uh-oh, in the discriminant, I get a -23. And that means that there are no solutions, and I stop working. No solutions because of that -23. There's nothing to sub in. There's no more work to do. I just stop. And it's very important, not only don't just stop here, but make sure you write no solutions. Okay? I'm going to say thanks for watching. And have a great day, and we'll see you tomorrow in class.